So today we'll understand the concept of sniffing or what sniffing basically is. We'll also see some of the tools, especially one of the tool, which is very handy when you work, in any, especially in, where networking is involved, which is Wireshark. Has anyone, in any of the lecture taken this session on Wireshark? Have you gone through that? Hello, am I audible? Hello, am I audible, guys?
Yes, sir.
Okay, please respond. So, have you gone through the Wireshark or not? If not, I'm just asking. So, if not, we'll go through that.
No, sir.
Okay, fine. So, it is one of the widely used tool in any organization, especially when networking is involved. You can also, if you want to check any traffic is flowing through your system or not, if it is reaching to you, as well as if you, as a perspective of sniffing, also, the attacker can make use of this Wireshark tool. So, no, basically, it can be used for both, ethical and non-ethical purpose. However, widely as an ethical hacker, you can use it for your own purposes. I'll let you know what are the queries for that, how we can, understand uh, the exact working of that tool. So, before that, we'll understand what exactly is sniffing. So, sniffing is basically, where, the attacker or, you as a part of, ethical hacker. So, you can monitor and capture all the data packets that are going through a network, maybe using some software application or any hardware device. So, in an organization, uh, you are connected to internet through various different devices. It may be hub. Hub is now not used, as that much because it is a kind of insecure device and also, not a smart device to use. So we have switches and routers as well. So this, what we can say. Sniffing happens usually at switch level. So either the attacker will attach itself to that switch, and he'll allow that switch to run in promiscuous mode. So that is that promiscuous mode is where all the packets are sent to all the host. So like what we can say, it is broadcasted basically to everyone, to who is connected to that switch. It will be broadcasted to everyone, and then that switch will act as a hub. Apart from that, it is also, this is one of the method. Otherwise, any, attacker will run some tools, and so like Wireshark, or there are other certain tools as well. So, Trick and Enable is one of the tools. So that tool will, help that attacker to sniff, or make sure that all the packets are going through him and he is able to see that packet. Also there are other methods as well, so we'll see that. So there is so this is how it works basically. So it allows attacker to observe and access the entire network traffic from a given point. So he'll place himself in the network, and all the messages, all the packets will go through him. uh, yeah. And this is, it is very dangerous when you are using any of the, what we can say, protocols which are insecure, which we saw, right? There are some insecure protocols like FTP, Telnet, or HTTP. So, these protocols, if are used in any of the network, or any of the organization. So it is quite you know harmful. As well as sometimes what happens is whenever you're connected to any public network, so you go to a cafe and there is open Wi-Fi that is present. So in that case, if someone comes and he opens his laptop and starts running the sniffing tools, so if someone is logging and he is using some insecure website, even the credit card payment gateways, sometimes they are not that much secure. So if you remember, there is one gateway where payment gateway thing is there, which is bill desk, I think. So that was also not secure. So if you're accessing and paying, making payment methods through any such insecure websites, attack if there is an attacker into that network and is sniffing all the traffic, so he'll be able to uh, see those sensitive information. Okay, so here it is. So he'll attach the attacker will attach himself to a switch, and all the packets and all the data will be passed through that switch to the attacker. Okay. So there are two types of sniffing. One is passive sniffing, one is active sniffing. So passive, as I told you, it may be through hub. So in directly, he is not involved anywhere. No one is waiting in the lobby, right? Just allow if anyone comes. So as I was saying, there are two types of sniffing. One is where, as I told you, he will attach himself to a hub. If someone is using hub, and if the attacker attaches himself onto that hub, all the traffic. So basically, if you are aware, there is a difference between hub and switches. Hub will broadcast traffic to everyone. So despite of whom the concerned person is, where the communication should be sent, it will broadcast it to everyone. But switch will not do that. He will not broadcast to everyone. He will probably check what is the MAC address, what is the IP address, and then route the packet to that concerned target. However, if it is more run into that promiscuous mode, then basically it will cause issue. But by if hub is there, then even that that is not needed. You just need to attach yourself to into that network by connecting to the hub, and you will see all the traffic that is going to and from your to and from that network. So usually it is outdated. No one uses hub right now. Even small cafes or small networks want to use. But still, if by mistake someone is using, it is very much possible that an attacker will sniff all your traffic. And the other one is sniffing, active sniffing, which is switch based. So where usually switch is there, and then you'll have to make some modifications, which will or which will make sure that the traffic has been passed to everyone. And there are different methods for that, where it is MAC flooding, DNS poisoning, ARP poisoning, DHCP attacks, switch port stealing, and spoofing attack. Basically, all these methods involve either spoofing your system to pretend to be someone else, or making sure that the table that is present in the switch, that is maybe switch, maybe your DHCP, maybe your DNS. So main, in that the goal is to make sure that the table is overfilled, and this causes issue, and that will mess the concerned device, maybe switch, maybe your DNS server, and it will broadcast the traffic to everyone. So the main uh, techniques are this: whatever you're seeing as poisoning or flooding, they'll just hammer or generate lot of traffic, and make sure that whatever the switch that is present or the DNS the server that is present, it messes it up, and then your traffic will be sent to everyone, and you can act as the as the, what we can say, you can spoof your device and act as that concern, or your target user. So that is what the motive, or the method behind all the types of attacks are. We'll see how it works one by one. Okay, so we'll first see. Yeah, same thing like whatever I told you. He'll just one method is, where he'll connect his first he'll connect his laptop to his switch port, then run some discovery tools to understand the topology, identify his network, sorry, his target, and then start poisoning the victim's machine by using one of the method of either ARP spoofing, or backflooding or anything. And so what happens is, because of that, whatever the target that the concerned person was supposed to go to, it will be sent to the attacker, and from which the attacker can then sniff the what we can say, the sensitive information, or whatever the credentials are that he wants to collect. So these are the protocols that are vulnerable to sniffing. Same thing that we discussed yesterday, right? These are the same tools. Uh, Telnet RLogin is another thing which is not used. So Telnet is still used, however. So Telnet is one of the protocol which is vulnerable, which sends the passwords, in the clear text. Same thing with HTTP, SMTP. Even SMTP uses the what we can say, port 25 is the one which uses which is not secure, and it transmits the data in what we can say, unencrypted, not in encrypted data. So however, there is another protocol which is used, which was on 5.7, so that is now used, which is a secure protocol. IMAP is also there. IMAP and POP are the what we can say, uh, insecure, used for transmitting mail related data. However, those are also now, not widely used. They're overcome by POP 3, or IMAP 4. So there now we have these new protocols which act as encrypted ones, and act as secure ones. Same goes with FTP. If you are using FTP server into your environment, obviously it is not secure. So SFTP is the one which is now which is widely used. So they add as a secure layer, and they work on encryption part. This one as well, SNMP. I don't think SNMP was present over here. So SNMP, I already told you, right? So SNMP V1 and V2 are the vulnerable protocols, and currently we are using SNMP version 3 in the what we can say, in organizations. So if, however, that those are, those are sent into encrypted format, so that makes it more secure. Also remember, this question may be asked in your exams and in your interviews as well, that at what level the sniffing works. So it works at your data link layer, because all this networking and everything, or IP address assignment and everything, that works on your network layer. So sorry, data link layer. So that is why the initial compromise happens at your data link layer. So there are some hardware protocols. I told you, right? There are two types of sniffing methods. So one is uh, using your software applications, and one is hardware. So these are the hardware devices. If they are attached into the network, they'll you will need to attach that into your network, and then your device to that hardware protocols, and then you can just sniff the packets. There are two things, however. So you need to have access to their what we can say, what a rack they have, their networking rack, where all their devices are present, and uh, you'll need to then purchase it. So it's a bit cost effective. So or I can say more costly part. However, these are if there is no method of detection directly as such, because whatever the tools that are there to detect such sniffing that is happening and everything. So those tools won't work on these hardware devices. So basically, it is not easy to catch these network packets, or sorry, these hardware devices. And it is very difficult unless and until. So it is important to have physical security, and no one easily gets access to your to your hardware network. So yeah, so they don't attach their hardware device into their network. So unless and until you have your very weak physical security over there, this won't work. However, if it is there, it is very difficult to understand that anything like this is happening, because all the tools work on your network that is happening. No one will be able to detect any hardware is attached into your or that is installed into your network. And these are the some of the hardware protocol analyzers: Keysight, Stinger, NetScout. NetScout is one of the actually reputed company, so they do have this one of the tool. Obviously, because this is also used for what we can say monitoring method also, or it is also one of the monitoring tool. So, but usually a attacker will make use of this for its malicious intent. Okay, so there is also span port. So it is a port that is configured to receive a copy of every packet that passes through a switch. Usually, this port is not enabled, at switch. So, however, if someone enables this port and they attach that protocol analyzer to that span port, this span port will, it is configured in such a way that all the packets that are going through that switch will be a copy of that will be sent out to that span port. Again, basically, this was made to make sure the monitoring is happening. So, however, attacker who can make use of this for his own malicious intent. It can attach that protocol analyzer, and he can sit on that protocol analyzer by attaching its laptop or desktop to that protocol analyzer, and then he can just get the copy of each of the packet that is going to and from. Again, like if this is a bit dangerous, because it is not easy to what we can say detect it. And it this analyzer should not only take the copy of the packet, but it will also decrypt those packets. So basically it makes it very difficult to detect it, and all your packets and every information will be exploited by the attacker. It is also known as port mirroring. So if someone asks you what is port mirroring, and instead of span port, so you can you don't need to get confused between that. You should know both the concept is same, just there is some other name for that. Wiretapping, you must have heard about this. So wiretapping is basically process of monitoring telephone and internet conversations by third party. You must have heard in a lot of movies and everything previously that wiretapping is happening and your phones are tapped. This is the same concept. So attacker connected to a listening device, which is a hardware or software combination of both, to a circuit carrying information between two phones or host on the internet. So basically, let's say if you have your ISP server or something, so either he will use some wiretapping method, which will allow him to listen to all the uh, traffic that is going between your internet and your, I mean, whatever your device and your internet, which is your ISP server, or it is also used for as a method of what we can say hijacking or monitoring conversation of on your telephone or your phone. So yeah, it allows attacker to monitor, intercept, access, and record information contained in the flow. So again, here also there are two types of wiretapping. One is active, one is passive. So active one, it will not only monitor, but it will also, it will also alter and inject its own data into that communication or traffic. Passive is the one who will only record or monitor. So it may happen that if you're sending some data, so let's say if you are trying to log into your any of the website, okay, it may be your banking or any of the uh, something which is related to your official work, you're not trying to log into your to that website. So in the active wiretapping, it will monitor and it will intercept the data. Intercept in the sense it will stop that data. It will collect that data and it will send out some wrong information. So let's say that someone wants to put his credentials into that. So what he'll do is he'll just modify some data or send that data. So there are different tools available for this. There are different hardware devices available for this, to which he or she will do that. Obviously, active ones will be the one that is easy to getting detected. Passive is bit difficult because it is not modifying or altering any of your conversation. This is also part of lawful interception. So it may happen that some legal authority has issued this, what we can say, and uh, what we can say, uh, approval for this. So there is there is some suspect, and they have asked the legal authority, it may be court or it may be some other legal authority, for permission to maybe tap their telephones, or tap the conversation, or whatever that conversation is happening onto the internet. So they'll provide the approval. Then they'll request for tap to ISP. So whatever this wiretapping and everything happened, it happens at the service level provider. So let's say there is someone who for which the legal authorities have approved, or there is some court order where they'll request for the wiretapping. So and the ISP is, let's say, of Airtel. So the Airtel will they'll they're contacted. So they'll the service provider sets an access switch, or tap onto that exchange router. So there is an exchange router which is the medium for that person to connect it to the internet. So this access switch, they'll provide, they'll set up an access switch, and from that access switch there will be a system for real-time reconstruction of your intercepted data. And then all that data is stored onto that storage system. Okay. And then all the data that is intercepted from your exchange router for those particular user or users, those all will be stored into this CMS, that is central management server, and it will be sent to the law, or it will either be sent or it will be accessible for them to check whatever they want, the data they want or they required for. So yeah, the ISP is the one, if there is some legal notice or something like that, or legal request where they want to tap someone's data or someone's activity over the internet. Then what are the sniffing techniques? So we'll see one by one. So there is MAC attacks. So basically, you must be aware what is MAC. MAC address is basically an address of the physical address of the device. So we all have your, what we can say, this MAC assigned to our systems. So In this case, this is IPv46. Where is my MAC address? Uh, I guess this we have assigned IPv6. Okay. So if you search your, if you put ipconfig, you will see your MAC address over here. And so basically, this MAC address is there is one is which will have that table, which will contain your CAM table. That is, it is a fixed size dynamic contain addressable memory, which is your CAM table. This CAM table, contains information about the MAC address that are available on physical port associated with their VLAN parameters. So there will be VLAN that is assigned to a group of systems, and there will be some MAC address. Okay, and it will also contain to which port they are connected to. So each which will have this CAM table which contains all this information. Okay, so basically this is the main concept where there will be a CAM table and it contains this information. MAC address you must be aware of that it is what we can say and total of 6 byte or 8 byte of data, and there will be some dividation of those what we can say those addresses that are present, which is your which contains your organizational unique identifier and your network interface controller, which is NIC specific. So these two are there, and then your two are there for unicast and multicast, and one is there for your global unique, and one is for the. So if it is in this part, if it is 0 or 1, it is either unicast or multicast if it is 1, and if it over here if it is 0, it is globally unique, and for 1 it is locally administrated. So these are the what we can say contents. It contains 8 byte of information, or it is 8 byte of data, which is your basically your physical address of your device. And the way this MAC flooding works, so this is how basically the CAM work base. So first we will say, so let's say this is a MAC for uh, for a device. Uh, it will send the ARP. So that is your address resolution protocol. It converts, or it maps your physical address to your IP address. So let's assume that a request is sent by a device for for reaching out to device B. So it will ask for the ARP for B. So uh, B is basically another device. So currently switch is not aware about the IP address of that B device. So it will broadcast the ARP. That is, it will broadcast the MAC address of A, B, and C. Then P will respond that I am machine B, and then A and B can communicate at that time also. Whenever this happens, whenever it broadcasts, so the switch will make its entry into the timetable that this is the IP address of this MAC, and it is connected to port 2. Then similarly, same thing will happen for machine C. If let's say machine B wants to communicate with machine C, then and it does not this switch does not have information about machine C, then it will broadcast it, and it will say that I am that particular machine. This is my address and this is my IP. And once that is done, then again that CAM table will be updated as per the next communication happens. So what happens when the CAM table fills up? So this will basically traffic floods on every port of the switch. So let's say now A, B, C are connected now, and your current capacity of that port is of that switch is just 3. So it will contain information for only 3 devices. So what happens is now if machine D is connected, and machine A wants to communicate to that machine D. But this data that is there, I mean the CAM table, it is full and it will not able to store that information. So every time machine A will send out the request, at that time it will broadcast all the what we can say, the ARP request for all the machines. So it will send to B as well, it will send to C as well, it will send to D as well, and then the D will respond and it will communicate. So communication won't break, but then the broadcasting will start happening, similar to what happens on the hub. And this is how the uh, MAC flooding is taken advantage of. So now what the attacker will do, now let's say switch has the capacity of 100, 100 entries. So if let's say the attacker is is what we can say, is placed into that network, he will try to make that CAM table full. So then that particular switch will start acting as a hub. Obviously now many of these switches don't have that much of less capacity. They'll have lot of what we can say, they have lot of capacity to storing that CAM table. However, if you have taken some low capacity switch, thinking that you won't require any high end traffic, because the devices that you have are very less. However, if some way the attacker gets into your network, he may try to flood, or make sure that he's making your switch as hub by sending fake addresses, or fake MAC addresses and IP pairs until the table is full. So for that, there is one tool that is MacOff, which is present in your Linux one. We'll see, how that, how what we can put. So this is the command for that. Okay, open your terminal to MacOff. I've already entered that. So what it means over here is, you have entered MacOff tool hyphen I. Hyphen I stands for interface. Then the interface through which your internet is working, which is your Ethernet 0. And then hyphen N stands for number. Currently, you can put 1000. So it will send fake request of your MAC and IP addresses, and it will send out to your switch. Yeah. So basically, this is how, now we have sent it for the less number. It is just 1000, but 1000 requests are sent. So if you want to perform some big attack, you can give a high number. But this is how, it has the MAC address pairing to your IP addresses. See, all these are MAC addresses, sorry, IP addresses binded to that MAC, to that IP addresses, binded to that MAC addresses, and yeah, those requests are sent. So at a one, just by single click, thousands of requests were sent. Now, if your switch does not have capacity, it will flood, and then you can easily sniff your traffic, for which you need to run your sniffer tool. Okay. So basically, first part is where you need to uh, make sure that either your switch is able to run into promiscuous mode, and that is done usually by running the methods like MAC flooding, ARP poisoning, and then you can then sniff the traffic. Then comes your switch port stealing. So switch port it uses MAC flooding to sniff your packet again, like it will make use of this MAC flooding technique. Then the attacker floods with host gratuitous ARP packets with MAC addresses as the source as his own MAC address as the destination. So basically, it will place himself between the target and the host, and it will force the basically force in the sense it will pretend himself to be that particular target, so that all the traffic instead of going to the target is sent to him. So in this case it will attach, it will basically attach himself to a port, and then he'll make sure that he'll flood he'll make to the MAC flooding or ARP poisoning or something like that, which will enable him to connect himself instead of the target. So target will get disconnected, attacker will send himself, connect himself to that particular port, and then say that I am the one who is actually the one that you want to communicate, and because of it all the traffic that is going to and from will be sent to that attacker. So yeah, so a race condition of the attacker's flooded packets and the target's host packet occurs. Thus, the switch must change its MAC address, binding constantly between two different ports. So after the MAC flooding, the switch will get flooded and everything. But whenever the new entry is getting made, at that time it will send first ARP reply. So let's say if the host is, or the target is sending out the ARP request, and then we get the ARP reply. At that time, the attacker must be, fast enough so that he will able to send that forged reply, and all the packets are then directed to to that attacker. So what are the methods to defend against these MAC addresses, or sorry, MAC flooding attacks? So basically you have to configure your port security on your switches. Here it is mentioned as Cisco switch, but other switches are also that much, you can enable those security measures. So, as a part of your security person, if, someone asks that, such kind of attack may occur, what we can do. So you can provide them this, security measures of where we'll have to configure switch port security. Then over there you can have maximum one VLAN access. There is some security violation restrictions that should be placed. Then aging time should be there. So after some time, so if someone sends the request, there should be an aging time after which the request gets cancelled, or new request should come. If some port is inactive, then it should be disabled. If for a longer period of time, no port should be inactive, because let's say if there is some port which is inactive for a long time. uh, why it is inactive? Because no one is connected to that particular port. However, it may happen that some attacker may take advantage that no one is connected to that port, so I'll connect myself to that port, and then he can perform such kind of what we can say, such kind of activities. So any inactive port should be disabled. Then there are also some SNMP server enabled trap port security. So that is also another configuration that is present onto your switch. So that is a bit high level. We don't need to get into that. But just for the overall understanding, is that such security measures needs to be taken on the switch part. Then we will see DHCP. I guess you must be aware how the DHCP works. So it maintains a TCP/IP configuration information, such as a valid TCP configuration parameters, valid IP addresses, and duration of the list offered by the server in the database. So usually, like the user will send out what we can say, its request as DHCP discover, and it will then be sent to DHCP server. Then DHCP will reply, uh, through that relay agent. It will respond, and it will maintain information about the mapping of the IP addresses and the host name. So basically it works, it provides your IP addresses to the user in the network. That is the work of the DHCP server. It may be static or it may be dynamic. If it is static, a fixed IP address is provided to you. If it is dynamic, your IP addresses will change with every new request. These are the request reply messages. So we don't need to, get deep into that. Just we'll understand, how the exact works. So basically, first it will be a DHCP discover for IPv4 and for V6. It's site. So client will broadcast to locate the available DHCP server. Then the server will respond using the DHCP offer or advertise for the configuration of parameters. Then based on that DHCP request, client to server either requesting offered parameters or confirming the correctness of the previously allocated addresses or extending the lease period. So it may be some time period or it may be some, for dynamic, it is usually some lease period. If it is static, then there is no lease period because it is fixed one. And then there is a DHCP ACK or reply where the server to client with configuration parameters included the committed and network address. So server will, send the configuration parameters and confirm the IP addresses. Then it will be DHCP release or release where it will, so client will send this relinquishing the network addresses or canceling the remaining lease. So, once the client is, done with that particular network, so it will release its IP address. DHCP decline is when this is sent from client to server, indicating that the network already is used. So if any already used IP address is being provided by a DHCP server, so that the client will decline the request saying that this is already in use. Any reconfiguring is when whenever the server is saying to client that it has a new or updated configuration settings, the client then sends either renew or reply or information request or reply transaction to get the updated information. So let's say if there are some new configurations that are made or some changes are done onto that server, then it will send these two packets or messages to check that or make sure that the client understands that we are sending a new request, or you need to send a new request to as we have got updated our configuration settings. Then comes your DHCP inform or information request where which is sent by client to server asking only for local configuration parameters because it already has your external parameters. So whatever your local network settings are there or your configuration is there for that time, this request is sent. Again, in your reply forward is for relay agent sends a reply forward message to relay messages to server. So yeah, this is communication between a relay agent to your servers. Same is with the relay reply where server will send the reply to the relay agents containing message that the relay agent then delivers it to client. So as a mediator, relay reply will be where the agent DHCP agent will send the message containing for the client. And the last one is DHCP and AKI, where the client indicates that the client notion of network is incorrect. So if the IP address is incorrect or the lease has expired, that time this message are sent. Then comes your DNS starvation attack. So that is where kind of a DOS attack. So whatever the request I went through those requests to understand how the DHCP basically what kind of messages are present, because an attacker may make use of those relay messages or whatever the messages are there that is sent using a forced DHCP request, and it will try to lease all the DHCP addresses available in the DHCP scope. So what DHCP starvation is, that it will basically make sure that the what we can say, all the requests are sent, and it will try to release all the leads. So whatever the time period that is allocated for those target, it should be released, and it will send out the forged DHCP request, so that the main user who is there, who wants to act, I mean, what we can say, the actual concern, or the legit person who wants to actually get connected to that particular DHCP server, he won't be able to connect it because the DHCP has run out of IP addresses. So basically, in simple terms, attacker will send lot of requests and make sure that the DHCP server is exhausted, and none of the, what we can say, there are no new IP uh, present for allocating it to the user. And this is how then it will make sure that this DHCP starvation attack is performed. That is what it is. And so it will send forced request to the switch. Like, this is my MAC address, and it will send lot of traffic. And for each MAC address, the DHCP will allocate one IP. And because of which, any actual user who is requesting for the IP address, he won't be able to connect. Then comes another attack, which is your rogue DHCP attack. So basically, it sets up a rogue DHCP server onto the network and responds to DHCP request with a bogus IP address. So basically, what it happens is, it will set up its own rogue server, and it will connect it to a switch. So whenever any target sends out the request, so instead of it getting redirected to DHCP server, which is your actual DHCP server, it will be sent to the rogue server. That is, the attacker server. He'll create its own DHCP server, and it will connect himself and pretend to be the one which is the legit one. So all the he'll be the one who will assign the what we can say, the IP addresses, and uh, then the attacker can send incorrect TCP IP setting. This will basically be achieved by providing wrong default gateway. So this gateway will be attackers, and the DNS server also will be attackers. So this works in along with the DHCP starvation attack. The attacker sends TCP IP setting to the user after knocking him out of the genuine DHCP. So once he has achieved this one, okay, first he will do this activity where it will make sure that your DCP server is basically out of scope, and it has run out of IP addresses to allocate, and then it will place its new rogue server into the network. So because of that, now new request will be sent out to the attacker server. So again, if you want to enable, if you want to defend yourself from this DHCP starvation and rogue server, so basically you need to enable port security, limit the number of users that are, connecting to a network. And also, and you can enable DHCP snooping, which allows switch to accept a DHCP transaction that is directed from a trusted port. So, there are some trusted ports and there are untrusted ports. So if anyone is connecting to untrusted port, then he should not be allowed to, his traffic should not be, what we can say, accepted. This is again done at the switch level. Then coming to ARP. So ARP is basically address resolution protocol. It is a stateless protocol resolving IP addresses to MAC addresses. So basically, it resolves your IP addresses from your MAC addresses. So let's say if when one machine needs to communicate to another, it looks up the IP addresses in its ARP table. If the MAC address is not found in the table, the ARP request is broadcasted over the network. So basically, let's say if again we'll take the previous examples. If A wants to connect to B, so he'll send out what is the MAC address of this IP address. Again, the switch may not have this information. Then it will broadcast it to everyone, asking who is this IP address concerned with, or to whom this IP address belongs to. Then it will return its MAC address, that I am that concerned person and this is my MAC address with the ARP reply. And then the switch will make sure that this entry is stored, or this entry is uh, added into the table. If you run the ARP here, you will see this binded table. What are the interfaces that I have? So to each IP addresses, this MAC table is sorry, this MAC address is binded with. Some are dynamic, some are uh, static. The MAC flooding and the DNS poisoning work in the same way. So the ARP spoofing attack is sorry, the MAC spoofing and the ARP spoofing is the same thing. That this they'll poison this ARP cache. So basically, again, consider MAC flooding as ARP poisoning. The attacker will send lot of requests, make sure that the table is full, and then any new request will come. It will then be broadcasted. Once it is broadcasted, the attacker then can either eavesdrop on that ARP request and response as and spoof as the legitimate user. So if you check this example, now your uh, ARP table is full because of the poisoned ARP cache. So basically, the attacker has poisoned, performed the ARP poisoning, and it has spoofed, and it sorry, not spoofed, but it has now poisoned, and now your ARP table is full. Now the switch will act as a broadcaster. So any new request that is coming, that what is the IP address of what is the MAC address of this IP address. So this request will be sent to everyone who is connected onto that network. So user A will send, I want to connect to this IP address, but I need MAC address. Now it is sent to switch. Switch will broadcast it to everyone. Then it will send to user B, it will send to user C, it will send to user D. User B will say, yeah, I am that IP address and this is my MAC address. Attacker who will be, in the listening mode for this will maybe intercept this, and before the traffic is being sent, it will stop the traffic from being sent, and it will uh, say that I am that particular user and this is my MAC address. So then instead of communication which that should have been happening between user A and user B, it will be happening between the attacker and the user A. So, these are the threats of ARP poisoning. So the attacker may able to, sniff packet sessions, or, he may also be able to manipulate data, uh, tap video calls, sorry, voice calls, or even video calls as well. But video call is not something, it works at different levels. So video call is not possible, but at least voice IP call, so it is available, so it is so possible. Man in the middle attack is also there, which is possible. So this is nothing but a man in the middle attack, which it pretends, it comes between the attacker and sorry, the two host, and place himself between the host and it will then basically act as that particular host, and then the communication will happen between them two. Then there is connection data interception, the same thing. Then connection hijacking, connection resetting. It can reset the connection. If they're using some vulnerable protocols, it will be prone to stealing of password, obviously, and denial of service. So whenever this happens, so let's say if he place himself between the client and the user, and if he floods this particular what we can say floods this ARP table and places himself between the target and the client. So then he can just he'll make sure that he's not able to take access of that service. So that is also then one of the one of the motive behind this attack. Then there are some tools which performs your what we can say ARP poisoning. One is your available on your Kali machine, which is ARP spoof. Again, the same what we can say same method. So you can just mention ARP spoof, provide hyphen as an interface, and then hyphen target host and your local machine. Currently, because of my secured network, so I'm not able to perform this. However, there is another tool, which is your Canon Apple. So it performs this. I'm still scanning my network. Let this get completed till the end of our lecture. Let's see if it is able to scan my network because it is scanning some wide range, and currently I just have couple of systems, so it is not able to reach to this particular IP address. Let's wait for some time, and then we will see how this tool works. So basically it is over here you can see, right, there is a sniffer tab. You just need to run the sniffer, and then scan those MAC addresses. Once it is done with the scanning, it will list all the what we can say, it will list all the devices that are present, and then you can perform the uh, ARP poisoning, which is this tab. I recommend you to download it. You will have to obviously turn off your antivirus for this, and also firewalls also, because any local firewall also, local in the sense your machine firewall also will not allow it to perform such activities now, because our security devices have become much more secure, so it will usually block that. But for now, let's wait, let's see how this works. So if it is able to scan these machines or blast it, we will see how this works till end of our lecture. Again, so how to defend against the RP poisoning? Again, your port security is there. You can also do DHCP snooping binding. So basically, once you have binded the tables, so even if new entry comes, you won't be able to. So it will be directly rejected. Okay, so basically, let's say if someone sends a new request that this is where a request will be sent, and in that case, if someone says that there is no entry, then discard the packet. So if we have enabled this DHCP snooping binding, so if a new entry comes or a new request comes, it will be directly discarded, and you won't be able to take it up. Again, these are all done on the switches. There are also some some detection tools. One is XARP. So I have that tool. So currently your security is sent to this one. According to him, there are some DHCP, sorry, ARP attacks there, where we can see. So here is the attack. IP address lies in multicast range. So if there are multiple IPs present in that same range, so that that he is considering as zero alert. So you can also check, log file, and you can also check the help how to handle it and everything. This is basically your pcap files, and these are all the requests that he's seeing. So yeah, you can install it as a part of your request. So basically, it is he's seeing lot of requests that are coming. So these are many requests that it is seeing. So this one gateway is there. So for that, cache is present. Apart from that, there is no cache present. And these are the internet interfaces. Okay, since I have installed the VMware, we can see some VMware gateways and everything. Otherwise, we can see only maybe these two we could have seen. So this is my gateway, and this is the my local machine. Okay, so this is also one of the tool, which is your XR. Mac spoofing and duplicating is the same thing. So again, it will spoof. It will initially it will do the poisoning, and it will send out the request, and then it will pretend to be that particular uh, target user. So it will act as legitimate user, and it will then intercept the data and act as that target user. There are some spoofing techniques you can, if you want, you can uh, provide your own, what we can say, your own IP address or MAC address. You need to go into this window sharing and everything in the properties you will see, and you just need to mention the value over here. Obviously, don't, go and try for this. It may happen that you may lose connectivity or something like that, but usually you can do that. Also, there is some tool like you have to do a lot of changes. So we'll have to also change in the registry, key registry. So over there also you need to change your uh, MAC address. So a lot of things you need to do. Usually, don't try to do that. This is just for your information. You may, lose your connectivity. However, there are some tools as well. Let's say for SMAC. So these are the network interfaces currently. And what I can do is I can just provide so this is my current MAC addresses. This won't work right now, but if I try to do it like uh, it will restart. See, alerts are also generated, and my Windows firewall is also blocked this. I'll try to allow. I'm not sure it will allow. Adapter is restarted. I'm not sure if this is I think this has detected it. So it has blocked it. However, you can load the list and you can just, try to spoof it. So yeah, these are the tools that you can use it. This one you can try because after some time you can restore it. This is similar to the SMAC. This is some different titanium MAC address changer. It's almost same. No difference in there. Then again, this is one of the other protocols, which is your SAMP discovery protocol. And it is a routing protocol that allows discovery of the IP addresses of active routers on their subnet by listening to router advertisement and soliciting messages on the network. So basically so this is used for, IP addresses, discovery of active routers IP addresses that are present onto their network, and then listening to that router advertisement. The attacker sends a spoof IRDP router advertisement message to the host on the subnet, causing it to change its default router. So basically, it is placing its own router, making sure that the attacker or so the target who is there, who is basically connected to his uh, concerned router gets disconnected, and then it will connect it to the attacker's router. This he will do it by sending out the false false, what we can say, false or spoof routed advertisement messages. Then in once he has done that, it can launch then man in the middle of or DDoS attack. Then you must be aware of VLAN. So virtual LANs are present. So this is one of the attack of VLAN hopping. It is a technique used to target network resources present on the virtual LAN. So it can be performed either using two primary methods, that is switch spoofing or double tagging. So this is usually where it will again place its servers on the he'll create virtual LANs, and then it will based on that it will place its rogue switch, that is your attacker switch, and make sure that all the traffic that is going to that switch is also sent to your to that attacker switch. Again, just placing of its own devices into the network. So now the concept remains the same, I guess. All for all, DSCP related, you just need to do the sniping, scoop binding, snooping, and snooping binding table needs to be enabled. DNS poisoning, again, similar to what we saw for MAC flooding or ARP poisoning. It is a technique which tricks a DNS server into believing that it has received authentic information when it has received none of that. So basically, again, this results in the substitution of false IP addresses at the DNS level. So it will basically poison your DNS cache, and it will then flood, and then the DNS server will send requests to everyone, which allows attacker to replace IP address entries for a target site on the DNS server. So let's say attacker has created some DNS web addresses or web what we can say web pages or web servers. Now, whenever the victims are there, they'll try to let's say they want to connect to one of their website, and attacker by some method has poisoned your DNS cache, because of which uh, the victims who are like they wanted to connect to that particular website. Now attacker has performed as DNA caching, and it has made his own entry uh, against that particular website, and because of which now the victims are getting connected to that web pages which the attacker has made. So this is how he or she will perform the DNS poisoning attack. So yeah, same thing. Like let's say if some person has sent out request for the IP address of a website, it will be sent to that router, and the attacker poisons the router by DNS poisoning, sends out the request that he has hosted, and he will be then redirected to that fake website, and then all the credentials and everything will be sent to the sniff that password, and then he will be sent to the real website. So once he has redirected to everything, he will be then, I mean, what are the motive of the attacker is there of stealing the credentials and sensitive information. Once it has done that, it will be then redirected to a real website. Proxy is the same one, like instead of DNS proxy, I mean DNS server, it will be just proxy server. Again, there are some tools. Obviously, now there is no point of using those tools. So, however, if you have, you can, if you want, you can perform this DNS poisoning tools. Uh, okay. So we'll see the Wireshark tools as well. So we'll again open up our Kali. for that. There is a packet that is netsniff. Okay. So I'll explain you how this works. Now, what we have done over here is uh, we have started network sniffing. This is a network sniffing tool that is NetSniff, and we have provided the uh, interface as your interface which we are running this network on, or this net on, and then we have what we can say, send out this all the capture whatever we are capturing, whatever sniffing we are capturing, we have we are what we can say, uh, mm, send out on this dump.pcap file. Now let this finish. Let's give it a minute. Let's see what information it is capturing, and it will, all this information will be stored onto your pcap file. So let's wait a couple of minutes. Let's see if much more information is getting captured, and then we will open up our Wireshark where we will see the results. Yeah, it has started this sniffing. Let's give it a couple of minutes. Let's try to learn something. Mm, Facebook is something which is of no use since it is in secure HTTP S1. But let's see if there we can see any of the this testing one. Let's see if this works. Now let's go to this. Yeah, okay, now and then let's look for our Wireshark. It stopped. Okay. We'll open up first we'll open up the one which is we have stored one. Okay, you can see the ARP ones, right? Who has this IP address? Uh, then you need to tell it to this particular. So this is my uh, Kali machine, and let's see if we are able to find that particular website username and password. We can also see like whatever the discussions that we saw, like how the working works for TCP and everything, connection and everything. So we can easily see what flags are set. Okay, so which flags are set, and what is the size of those packets. See how is the what we can say in this acknowledge and sequence this which flags are set. So here you can see push flag is set. So all this information and everything we can sniff into this uh, from this Wireshark tool. Looking for that particular packet, if it is able to capture it. I'm not sure about the port number. So basically, you can load those pcap file if if you are looking for some particular payloads or particular traffic that you want to do the analysis for. I'll tell you how more queries we can put. I'm just looking if I can find that particular packet. I'm pretty sure this insecure one should be able to capture the uh, username and passwords. Okay. Let's do one thing. We'll run a new one. This is our internet, and it has started capturing again this one. We try to again load this one. Yeah, again it has started sending out. Okay. Uh, see over here, right? This is the, and over here we will be able to get the, let's see. Till it should come over here. We'll see this. I'll get back to you regarding this. But ideally, we should be able to see this particular username and password because we are using HTTP. These sites are HTTP, so we should be able to see those types of packets. Still, we'll try. Let's say p dot s. Mm, mm. Okay. So anyway, we are able to sniff the traffic at least. I'll also show you next time like how we'll get the password. But I'm pretty sure in this packet itself the uh, username and password should have been there. So this is because this is the login page that we are seeing, and over here in the some part there should be some uh, username and password. I'll show you next time for this. However, this is how you can search for if you want to run for any particular port, or let's say if you want to run for particular any of the uh, uh, traffic. So as I did right now, right? So I have understood this is the IP address of the what we can say the server, or the website. So I just added over here query as IP address, IP dot address equal double equal to, and that IP address of that server. Now if you want to add IP dot, I mean I want to provide the source address for any machine, and I want to just look at the traffic that is coming to and from that particular server. So I can just add this query, and it will then show me the traffic that is only going from that particular machine. Now here that machine is our this Kali system. However, like whenever if you are sniffing any traffic or something like that, and you want to check traffic coming from only that particular port, sorry, that particular device, then you can certainly add this IP dot source query. So, it works for different queries. So if based on your requirement, you can add for particular port, particular destination, or, if you just add IP dot address, you will receive the traffic going to and from that particular servers. Okay. And this is very helpful as a part of sniffing tool. So sniffing also, so understand how the traffic works. Like I told you, right, we saw in the first few packets which we saw regarding the ARP. So whatever we discussed right now, how the ARP works and everything, which sends out the request and checks who is that particular user, machine having this ARP, or this IP address. So how the requests are sent and everything, we could easily see from the Wireshark. So eventually this is a quite good tool and a powerful tool. And you can also see how many packets are what packets are sent, which extensions are used, if what type of protocol it is used. Again, like key, what are the key extensions? So you can see the hashed keys. uh, Again, like I told you, for HTTP packets in using HTTP and FTP, you will easily see that passwords and username. Right now I'm not sure why we are not seeing that particular username field and password field, but uh, if I'm able to find out till next time, I'll surely let you know how we can do that. But with any which way, like no one uses HTTP website now. But however, there are some government websites which do use, and from them you can easily get this. Once you run this sniffer and you are into that network, you will easily see that particular traffic. So yeah, this is how the powerful tool is. Let's see if it is able to discover the. Uh, yes, still not it is able. So I'll recommend you to download this tool. And once you have done this, you just need to start the ARP poisoning. You have to come into sniffer, then start the sniffer in this symbol. And this is the add button. Once you have added that, it will display uh, all the devices that are present onto a network, and you will able to see your devices, and then you can do the ARP spoofing. Right now, any which way, it is not that much useful because we just have two systems. One is VM and one other one is this local machine. So any which way, if you are able to do that, it won't be of any help. But just to showcase you, I wanted to show you, but it is still not discovering. So let's see in the next part or something, if I'm able to show or something, I'll let you know. Fine, then any questions on this topic? Also, you have only one person is left. Okay. So you have your practicals in the next exam, right? Next Saturday.
Saturday there will be an exam.
Yeah, fine. Fine, just go through the modules and recordings and see if there is anything that you need, you can ask me.
So can you please share some PPTs or some notes or that
So
will be
I'll
helpful.
share the modules that we discussed and also share the PPTs that we saw,
Okay.
that we studied. Just send me your email address
Okay.
over here, ping me. I'll send it out.
Okay. So actually, other faculties will giving a question bank. So
Okay, I'll do that.
okay, sir.
By tomorrow, day after tomorrow, I'll provide you that.
Okay. और सर सिलेबस क्या होगा?
यही जो हमने जो मॉड्यूल्स अभी तक देखे ना,
ठीक
मोस्टली
है
दो
मतलब
इट विल बी,
आज
हाँ
आज तक
सिनेरियो
का
बेस्ड
पूरा.
रहेंगे। हाँ
ओके.
हाँ, सिनेरियो बेस्ड रहेंगे, जो भी हमने पढ़ा है उसके सिनेरियो बेस्ड क्वेश्चंस रहेंगे।
ओके सर. ठीक है.
ये जस्ट पिंग मी और आईपी, सॉरी, ईमेल एड्रेस,
email.
आई विल
ओके.
सेंड आउट। और बाकी को भी होंगे तो उनको भी दे देना।
ओके सर.
सेंड आउट इमीडिएटली।
तो मैंने भेज
हाँ
दिया है.
हाँ हाँ, मैं सेंड कर देता हूँ
ओके.
5-10 मिनट में। ओके फाइन, थैंक यू।
थैंक यू.
सावन चल रहे मुझे पता है, मैंने चिकन अंडा कुछ भी नहीं खाया था सर। और मैं मंगलवार, बृहस्पतिवार और शनिवार बिल्कुल चिकन और कुछ नहीं पीती थी। मेरे को भी ऐसा चल मैं तुझे एक कहानी सुनाता हूँ, के बाद तू डिसाइड करना कि तुझे 72 आई मीन स्वर्ग चाहिए या नरक चाहिए। तो एक बार एक मुजरिम को जज के सामने पेश किया जाता है। जज उससे कहता है कि क्योंकि तुमने बहुत सारे मर्डर किए हैं, इसलिए तुमको फांसी होगी, तुमको सजा दी जाएगी। लेकिन वो रोने लगता है और कहता है पर जज साहब, मैं तो केवल मंडे, वेडनेसडे, फ्राइडे और संडे ही मर्डर करता हूँ, इस हिसाब से तो कुछ होना नहीं चाहिए मेरे साथ। जज उसको छोड़ देता है। अपने मन से ही बना लेते हो क्या कि दिन भर के नहीं खाएंगे तो पाप नहीं पड़ेगा, तब पाप करता है चला कर नहीं तो पाँच के बाद चले